Folks, hi and welcome to Kotlin Conference. So happy to see you all here. My name is Kier, and I'm a Kotlin developer. Well, I'm also a JetBrains CEO, but who cares about that here and today, right? At my heart, I'm still an engineer, someone who really loves code. A few weeks ago, I dug our commit history and found the first piece I ever wrote in Kotlin at JetBrains. Just look at that. Isn't it funny? As if somebody tries to write C# code right inside IntelliJ IDEA. But that's for a reason, because this is one of the first files for Rider, our .NET IDE, so you can understand the legacy here. The interesting thing about this piece of code is that it was written in January 2015, long before the official Kotlin release. Why? If you haven't heard, JetBrains is a company with a crazy engineering-driven culture where engineers, developers, us, trying to adopt all these new cool things as fast as possible. New languages, new frameworks, new tools. And back then in 2015, Kotlin promised us great readability, flexibility, safety, and interop with Java. And as we know, all of these things paid off really well. Now, one of the coolest things I was so passionate, and now I am so passionate about Kotlin, is that our test engineers and engineers could write tests like this in a natural language. But this is 100% legit Kotlin code. Thanks to all these fancy features like Lambda with receivers, global static methods, you can basically write it in English. Isn't it cool? And this was real in 2015. Now, 10 years later, Kotlin is everywhere. Just think about it. Roughly 1 out of 10 developers worldwide is programming in Kotlin. And its adoption continues to grow. We built Kotlin for developers, but also by developers, by us. This is one of the greatest things we built at JetBrains. And honestly, we couldn't do this without you. Kotlin thrives because you, the community, built libraries, thousands of libraries. Kotlin evolves because you provide your feedback, you embrace curiosity, you exchange ideas. Kotlin grows because you spread it out across the world. So Kotlin is as much our language as it is yours. My dear Kotlin community, thank you. Thank you. Now in 2025, building such an impactful thing as Kotlin indeed puts us on a crossroads of what's happening in the industry. And oh my gosh, so many things are happening right now. I think you're familiar with all these buzzwords like new revolutionary AI framework tool, some bold statement of some CEO and all this stuff, right? Yeah, you get the point. And some of the things go viral and fade away even before we actually try it. So, I don't know, yeah, you gotta have 48 hours per day to stay on track. But the fair question here is, where is the place of JetBrains and our beloved Kotlin in this mess? And since we are as I said already, very much engineering organization. Honestly, we've never been, and we are not hype chasers. So we are not building AI just for the sake of AI. Instead, we get only those things, only those promising, real, tangible things which really increase what matters for us, for JetBrains. They increase productivity and bring joy. And today, we are confident that yes, AI can really improve our real engineering lives. So we put our long-term AI bets on three main areas. First and foremost, we just released Junie, our AI agent. We actually released it in April, and we already got enormous amount of very positive feedback from thousands of developers, real developers. And again, we've not just released yet another AI agent. We were not targeting it for wipe coding of pet projects or some synthetic benchmarks. We created Junie from the day one to be capable of solving real industrial professional tasks. And it does so. And it does it really well. It's really magical. Please try it if you haven't. And of course, it works perfectly for Kotlin. Now we are working to combine two very powerful technologies, Junie and Kotlin multi-platform, so you can use their power to build Kotlin apps on all the platforms. Secondly, we constantly integrate the best from the AI industry into our IDEs, our tools, whether this is code completion or unit test generation or commit message generation, other fancy features, but we battle test these features against you, real developers' feedback. And we introduce the free tier for all of these AI features for all of our IDEs. So they're now available for much wider developer audience. And of course, we're working really hard on our beloved Kotlin to be the best programming language in the age of AI. Age where, well, maybe majority, or at least a lot of code will be generated by AI, right? So we create our own models, we build our own models, which produce really high-quality Kotlin code. We integrate these models into our tools. We open source this model for community. We partner with leading AI companies such as Anthropic, OpenAI, Amazon, Google. So the industrial LLMs also produce higher quality and up-to-date Kotlin code. Kotlin's readability, flexibility, and safety makes it a perfect target for AI generation, right? So I'm really happy that all those design choices we made back then, and I was so passionate about in my first example, they're even more important than ever. So let's explore all these new innovations, all these new technologies. Let's do what we developers love to do, deep dives, here at KotlinConf, and let's have some fun. And to kick things off, please welcome Mike, the lead language designer for Kotlin.
Good morning, everyone. Kotlin continues evolving, and there's tons to talk about regarding language evolution. And first, we start with the release of Kotlin 2.2, which is available as release candidate. 2.2 stabilized quite a few language features that we've already talked about before, such as guard conditions, multi-dollar string interpolation, and non-local break and continue. It also brings context parameters to beta stability. K2 mode also becomes the default IntelliJ IDEA 2025, which means that now your IDE uses parts of the much faster K2 compiler. And to get an understanding of how much faster the K2 compiler is, I want to show you two key results that I'm particularly excited about. First, let's look at the compilation time for the IntelliJ MENA repo, which includes nearly all our projects at JetBrains, covering over 12 million lines of code in Kotlin. And you can clearly see when we turn on K2 mode for the repo, compilation time went down by about 40%. That's huge. Another result, comes from Google. For them, build times for Android Studio went down by about 30%, not on C-setting benchmarks, but on their real end-to-end builds. Build speed was one of the motivations for building the K2 compiler, so it's great seeing these improvements. But we had another key goal in mind, too, and that's the ability to introduce language features at a steady pace with quality in mind. Because we want to make Kotlin continuously more ergonomic, improve its type safety, and make the core feedback loop faster. And there's a number of coming language features that I want to share with you today, and so let's explore them. The first one is about positional destructuring and data classes. Currently, if you have a data class like talk with the properties title and speaker name, Kotlin allows you to destructure it into its primary constructor properties, like this. But it's relatively easy to make mistakes here. Here, we assign the property title to the variable name and the property speaker name to the variable title. That's very likely not what you want. And the main issue is that you can't really spot this mistake without checking the declaration of the talk data class. To mitigate this problem, we'll be introducing a new feature called name-based destructuring. With name-based destructuring, you move the val keywords into the parentheses. And that indicates that each variable binds with the same property of the same name. With this approach, the compiler enforces that the names of our variables are the same as the names of our properties. And that prevents our mistake, because now the compiler emits an error that such a name and property doesn't exist. Changing the name to speaker name fixes the mistakes and makes the compiler happy. The name-based destructuring feature involves a few migration steps, and to get it right, we'll be rolling it out gradually and presenting as experimental in Kotlin 2.4. Before moving on to the next feature, I'd like to briefly highlight how our nullability system interacts with error handling. Imagine we have a function fetchUser that returns a user object or null if it fails. Also, we have a function charge that charges the user some amount of money and returns a transaction ID or null if there is an issue. Next, how can we use these functions? Well, we can fetch a user and attempt to charge them, but the compiler prevents a direct call to the function charge, since there might be a fetching error. Good. It actually forces us to use safe call or check for null. So let's use a safe call. Now we can safely charge the user some amount of money and report an error if the operation fails. The code is simple and elegant. It's almost perfect. But since we are using null for different types of errors, it's hard to tell where the error happened, when fetching the user or processing the transaction. And there are several ways to handle this, but they can be quite verbose and not very flexible. And we believe we can do better. So let's look at our new feature that we call rich errors, because rich errors are designed to support this common error handling pattern at the language level. So we start with the same functions, but now they return not a nullable type, but their main type or an error. For instance, fetchUser now returns user or fetching error. And the function charge now returns transaction ID or transaction error. Where fetching error and transaction error are regular declarations marked with the error modifier. Next, what happens with our code? Same as before, the compiler prohibits a direct call to the function charge, since there might be an error. Good. And also, same as before, we can use our safe call operator. But this time, instead of checking for null, we get full information about the potential errors. Rich errors generalize the concept of nulls as errors. And our plan to introduce a first preview of this feature in Kotlin 2.4. And while we are here, let's take another look at this piece of code. Here, we charge a user a large sum of money and report that the transaction completed. However, we know that the operation might fail. That's right there in the function signature. And without proper error handling, we could leave our user in an uncomfortable situation, unsure whether the money was actually charged or not. And I don't know about you, but I've definitely been in those situations. And this is where our next feature comes in, must use return values. The feature prompts us with a warning if the return value is not used and simply ignored. Because most functions that return a value do so for a reason. Ignoring the return values is almost always a mistake or code smell. And actually, as well as letting errors slip by. So if you thought the compiler will miss a branch, that's not the case. The compiler will ask you to put a missing branch or to write an else. Our plan is to make the must-use return values feature the default behavior everywhere. And to get there, we'll be rolling it out gradually. We start with our libraries. And in Kotlin 2.3, the standard library and Kotlin X libraries are marked with special annotations that trigger the unused return value checker when you enable the opt-in. And from there, we bring it to more libraries and ultimately enable it by default for all the application code. The next update isn't about language features, so we can take a moment to relax. Instead, it focuses on the compiler API. Kotlin compiler plugins can unlock entirely new programming paradigms, or simply improve existing ones, like our NoArg and AllOpen plugins help integrate with Spring, and the Compose compiler plugin enables declarative UI development. We truly value this, and more importantly, see more and more new compiler plugins emerging. We also acknowledge that unstable compiler API slows development and increases maintenance costs, as almost every Kotlin update requires changes. However, with the K2 compiler, we are gaining confidence in the stability of the compiler internals, something that had long been an open question for us. And so, finally, we are experimenting with a more stable format for the front-end compiler API to make it easier to add custom checks and code generation extensions. And there's one compiler plugin I'd specifically like to highlight, which is the PowerAssert plugin. As usual, let me start with a problem statement. Imagine we have a class mascot that has properties language and name, and a simple property that holds Kotlin's mascot information with a small mistake. And I want to write a test which might look like this, just an assert equals, checking that mascot.name is equals to Cody. So what happens when I run it? Well, because I use the wrong name, I get an exception. But the first thing I see is that I got the order of my arguments wrong, so expected and actual are backwards. But also, this error message isn't that much useful, so I'll probably spend some time debugging my test. And here's how it approaches with the PowerAssert plugin, where I can write what's probably the most natural code ever, just checking the assert without any specialized assert functions with regular equality. Now, when I run my test and it fails again, I get all the specific values that I use in my assert expression. PowerAssert will become part of the language. And as this first step, we've moved it to the Kotlin monorepo and simplified its configuration. But here, I'd like to pass my word to Vsevolod Tolstopyatov, Kotlin project lead, who will tell you more about this.
Thank you, Michael. Great to see you all. The thing I really like about PowerAssert is that it feels like it's a natural part of Kotlin. It doesn't force you to learn any new features or technologies. It does not introduce any new concepts. It's just here, and immediately it makes your development experience much more enjoyable and friendly. But what if you want to leverage the Kotlin ecosystem at its fullest? To use Kotlin first serialization framework, to preserve the backwards compatibility of the code you're writing, to have beautiful documentation with Docker, or to ensure the quality of your work with Kotlin Xcover. For that, you'll have to configure and enable all these capabilities explicitly in your build system of choice. And of course, you have to do it along with Kotlin. But then you might want to tweak the outcome, to have, let's say, more granular API validation, to cross-reference external documentation, or to customize your coverage reports. Suddenly, and all together, it doesn't look that joyful, simple, or natural to Kotlin. It's pretty clunky, it's not recognizable, and all these configuration blocks, they slightly differ from each other. For sure, we can do better. And moreover, the ecosystem is not only about plugins or configurations, it's about everything, libraries, language, and how everything is connected. So if we'll just add libraries to this picture, we'll get something like this, something disconnected. Every tool has its own unique name or a different naming scheme. And versioning policies are completely different and awkward. Every tool and library has its own. And as a result, for example, it's really hard to figure whether Kotlin X datetime here is compatible with Kotlin X IO, and whether they both are compatible with Kotlin 2.2. Probably you'll have to look it up somewhere. But we're an ecosystem. We can evolve. And we all know that all these tools are essential part of Kotlin, core part of Kotlin. So there can be only a single version, the Kotlin version. In fact, we don't even need any names. We can get rid of them. It's all just Kotlin. Kotlin documentation, Kotlin coverage, Kotlin validation, Kotlin power assert, all built into all build system packages, available out of the box, consistent, convenient, and familiar. The same principle we can apply to libraries. And instead of having a variety of coordinates and version, just have the Kotlin ecosystem with everything discoverable with a few keystrokes and automatic versions alignment. So you don't have to care about versions, coordinates, and whether they are compatible with each other. You have just the Kotlin ecosystem, just single Kotlin version, and everything what is available in the current Kotlin edition. This is going to be a multi-year effort, spanning across multiple releases, involving every part of Kotlin, language, libraries, tooling, everything to provide you the seamless Kotlin experience, as good as it gets. And some parts of it are already experimentally available starting from 2.2, and others will be in upcoming releases, so you can have better and better Kotlin developer experience. So we started with quite a setup: libraries, coordinates, versions, and then it ended up with a simpler and more elegant way to start a Kotlin project. But can we do better? What if we didn't have to configure anything at all? What if we had something natural to Kotlin, something built with a Kotlin support in mind from day one? Something like this. Something as simple as one-line configuration file, without anything extra. That's the power of Empa, our experimental Kotlin and JVM build tool. Like Kotlin, Empa is toolable, developer-friendly, with a clear configuration path, IDE support, and error reporting. And of course, it supports all the Kotlin capabilities, whether you're writing a multi-platform application, a backend implementation with Spring, a Kata client, or a command line tool. And as my personal favorite, Empa is a completely self-contained build system with a beautiful command line interface that can be used in any environment and with any kind of tooling. Currently, it is experimental and is road to alpha, with the goal to be the Kotlin and the JVM build system. Fast, pluggable, toolable. So check it out, try it, enjoy it, and most important, have fun with it. So Empa joins a variety of build tools in our ecosystem. And in order for a build system to support Kotlin, it has to account all the Kotlin capabilities: incremental compilation, language configuration, compiler plugins, daemons. And that's a lot of work. That's a lot of repetitive work, because each build system has to do that. So instead, we're introducing Build Tools API, fast, universal, unified API layer that abstracts away Kotlin for any build system and provides the same experience for any Kotlin user, the best experience. How does it help, though? Now, for a build tool to integrate with Kotlin, it is enough to support a single Build Tools API entry component, and it will take care of the rest, providing as good experience, Kotlin experience as it gets for all Kotlin users of your build system. Build Tools API is experimental starting from Kotlin 2.2. And we are already using it in our Gradle and Empa integrations, with more to come. So we are strengthening our ecosystem in every front: language, libraries, tooling, build systems. But the last but not the least goes Kotlin Foundation. I should mention Kotlin Foundation, the foundation that helps us to achieve our mission of Kotlin everywhere. This year, is getting stronger as two new members join Kotlin Foundation, Block, Inc. and Meta, as silver and gold members. With the help of all these members, for the last 2 years, we've been recognizing and rewarding the most outstanding contributions to the Kotlin ecosystem with the help of Kotlin Foundation Grants Program. So let's applaud to year 2024 Foundation Grant winners, these amazing libraries. And of course, this year is no exception. So if you're an author of open source library that enables a unique use case, covers a well-defined domain, or operates in an impactful area, such as Kotlin multi-platform or tooling around AI or large language models, we'd love you to apply. And here, I'd like to pass my word to Sveta to talk about enticing world of AI.
AI is changing what's possible in software, both for users and developers. Companies now see the value of what they can build, from chatbots to code generation and new ways to interact with your software. AI capabilities are now becoming expected in enterprise applications, and you can develop all of this in Kotlin. When you integrate AI models into your workflow, you use a typical AI toolset that helps you to solve standard problems. It includes concepts like chat memory, RAG tools, or agents. Together with the community, we've built a bunch of libraries to provide you with this essential AI toolset. They work on different levels, depending on the complexity of your use case, from low-level model SDKs up to agents. You can work directly with an OpenAI provider, with an model API provider like OpenAI. They promise to release their Kotlin SDK soon, but so far, you can use their Java SDK. By the way, it turns out to be written in Kotlin. If the Claude model works best for a use case, you can use an official Anthropic Java SDK. By the way, it's also in Kotlin. But usually, you don't need this low-level access. You use a high-level library that allows you to easily switch between different model providers and come with a whole bunch of extra features from this AI toolset. One of these high-level libraries is Spring AI. It contains some Kotlin-specific functionality, like the ability to register a Kotlin function directly as an AI tool. Like, for example, here, we define the getTalks function and register it as a bean. And then you can prompt the model which talks at KotlinConf 2025 are related to AI. And then this function, because it returns the list of the tools the model can use it, and come back with a whole bunch of the talks. And if you want those covering Spring AI specifically, you can reward your prompt and check the sessions by Rod and Sebastian, which would go right after the keynote. You can take your AI integration up a notch by adding an agentic layer. AI agents are now becoming the way to build advanced AI applications. That's because to get something useful from an LLM with a real-world impact, you need to give the model access to the tools and provide feedback back to the model. And that's essentially what agents are all about. A tool is a function, however complicated, a regular piece of software. Anthropic last year released a protocol to standardize an interaction between agent and tools. We released the Kotlin support for that. That means you can provide your agents with the tools implemented in Kotlin. For example, as a conference API provider, you can define an MCP server with the getTalks tool. Then it becomes easy for third-party agents to use it. Kotlin is used in production for many AI-powered systems already. And one story I'm pleased to highlight is Deutsche Telekom using Kotlin to build their LLM-powered chatbot, one of the biggest chatbots in Europe. Check out Patrick's talk to learn more about that and about Arc, a framework that was born out of their experience. Another company, Pretty Large, with a lot of AI functionality written in Kotlin already in production, is actually JetBrains. And to speed up our own developers who are working on AI features all over the place, we've built a framework that we want to share with you. And today, we're open sourcing Kug, a framework for developing AI agents in Kotlin. It comes with a bunch of predefined workflows and patterns, which you can use directly or combine. Here, we define a simple banking assistant agent working with GPT-4o. You give it your OpenAI API key, provide with banking tools, set up a tracing feature, and that's all in one function call. You can then run it with a user request. If your agent logic becomes complicated, it's typically expressed via a graph, representing the actions, nodes, and conditions, edges, to go from one action to the next one. In this example, we use LLM to classify the user request, and then, depending on the result, we route it to either a sub-agent responsible for transferring money or a sub-agent responsible for analyzing transactions. If LLM was not able to perform classification, you can decide to ask the user to clarify what exactly they want, and then ask LLM to classify the updated request again. So your graph can contain backwards, edges, and cycles. This way, you can express rather advanced logic in a Kotlin DSL, and then you can share it with your ML colleagues who can understand it, even without knowing Kotlin. What's more, with automatic tracing of each node and edge, you can observe what your agent is doing and reason about its behavior. This framework is based on a real experience of our JetBrains engineers, and we hope you'll find also it useful. To sum it up, Kotlin is a great fit for developing AI-powered apps, including sophisticated agents. Let's now look at it from a different perspective. How AI can help you develop Kotlin apps, be it server-side, mobile, multi-platform, whatever you want. At JetBrains, we build AI to boost your productivity, to make your work more enjoyable. It handles the boring stuff, so you can stay focused and in control of your code. You'll find AI-powered features throughout JetBrains CDs, helping out exactly where you need them. You can chat with your code base, ask questions about your project, and it'll gather the relevant context to provide you with accurate answers. The code completion is powered by Melon, a large language model from JetBrains. Melon focuses only on coding, and because of that, it's really good at it. It's designed to be really fast, to work in production on large code bases, and to make suggestions that actually make sense for a project. Moreover, there is a version of Melon fine-tuned specifically for Kotlin. And today, we're open sourcing it to make it available for the broader developer and research community. AI changes how we develop software. Do we write code, or does AI write code for us? Recently, we released Junie, a coding agent from JetBrains. Junie can perform pretty complicated tasks. For example, you can ask it to implement a feature that shows a random talk in the Kotlin config. Then it creates a detailed plan of what needs to be done and starts implementing it item by item. Junie is very good at following the patterns already present in your code base, while keeping you in charge of architectural choices and project vision. You can check what Junie is doing exactly by following the changes it made to the project at each step. It can compile code, and if something doesn't work, it can fix the problem by itself. It can also run tests to make sure they pass. Look, now the dice icon appeared at the top. We can click on it, and indeed it shows us a random talk. And it was all implemented by Junie. I must say, the future is already here. Junie is much more than a productivity boost. It's a new way to write code. You might say, I like Junie, I tried it and liked it, but it's not that fast. The screencasts are clearly sped up. Yes, coding agents take their time to think. So, we've been experimenting with running Junie in the cloud, letting it, for example, fix GitHub issues and contribute to your project. How does that work? You have an open issue on GitHub. You tag Junie, and it's ready to help. It starts solving your task. When it's ready, it creates a pull request with a fix, which you can comment on, asking for further improvements, just like with a regular contributor. When you are satisfied with the result, you can merge Junie's pull request into your project. In this way, you can even ask it to work on different issues in parallel. We are going to open the EIP program for Junie on GitHub soon. Stay tuned. Junie works for any types of applications, server-side, Android, and we are working to make it especially good for Kotlin multi-platform. And now, I want to invite Martin and Kate to talk more about Kotlin multi-platform.
Thank you, Sveta. We would love to talk about Kotlin multi-platform. So, Kate, should we start by explaining what KMP is?
Actually, no, because I don't think it needs introduction anymore. It's a stable, mature technology, and it's flexible enough to fit any kind of project, whether you're starting something new or scaling a large code base, working alone or with a huge team of developers, building apps with shared or fully native UIs. So let us break down what's new and exciting across the ecosystem.
We'll start our updates with the IDE, which is at the heart of the development experience. We are now providing KMP support with a brand new plugin, which you can use in your favorite IDE, whether that's IntelliJ IDEA or Android Studio. With the plugin installed, you can create new multi-platform projects within the IDE using the KMP wizard. Then, once you have a project open, pre-flight checks will ensure that your environment is set up correctly and help you fix it if it isn't. You can also work seamlessly with both Swift and Kotlin in the same project. In this example, we have a Swift UI view that calls into a Kotlin class, and we can both navigate and debug code across language boundaries. And of course, you also get support for Compose multi-platform, such as previews, which are now available for your components, even in common code. We're really excited. We're really excited for you to get your hands on the new plugin, and you can get it today from the marketplace in IntelliJ IDEA or Android Studio.
Next up, we have some updates for Swift Export. Swift Export is a tool that generates an idiomatic layer of Swift code for your Kotlin APIs, which makes calling into Kotlin from Swift much nicer. To implement Swift Export, we need to map every Kotlin language feature into Swift APIs from the ground up. The team has made a lot of progress since last year, and we now have most core language features covered. This all will be included in the first experimental version of Swift Expert, which is coming in Kotlin 2.20. We will then continue adding more features, such as highly requested ones like coroutines and flows, coming soon.
And now, let's talk Compose. Compose Multiplatform is the UI framework for KMP, allowing you to share UI code between iOS, Android, desktop, and web applications. It already powers the experiences of millions of users, and there are more and more companies who are choosing it every day. And we know that many of you have been waiting for one specific thing. Yes, iOS is now the third stable target for Compose Multiplatform, joining Android and desktop. This means you can confidently use Compose Multiplatform in production and build beautiful cross-platform apps with a fully shared Kotlin codebase.
The beta release for iOS was already 90% there to being production ready. But since then, we've completed the other 90% required before we could be proud to call it stable. Let's see what that means. First and foremost, a stable release comes with stable APIs and strict compatibility guarantees. So you can build your projects on Compose Multiplatform without having to worry about breaking changes in new releases. Compose for iOS includes resource handling, navigation, interop with native views, and first-class accessibility support, so you have everything you need to build beautiful, feature-rich apps.
We also know how important it is to deliver an experience to iOS users that feels truly native. With Compose Multiplatform, your apps will have scrolling behavior that's indistinguishable from native. Text editing with iOS native selection and right-to-left support. Support for drag and drop, as well as variable fonts. And behavior that respects user preferences, like contrast and font size. And yes, you can now use swipe gestures for navigation that feel natural on iOS.
Last, but certainly not least, a stable release comes with great performance. Our top priority for this release was rendering performance, and we're happy to say that Compose Multiplatform matches the frame rate of SwiftUI in our scrolling benchmarks, even on high refresh rate devices. Using Compose on iOS has minimal overhead, as it adds less than 10 megabytes to an app download size, and we are going to optimize this even further. And finally, Compose iOS apps have startup times that are comparable to native apps, which means your first frame arrives just as fast. Thousands of apps have already proven that Compose Multiplatform is ready for iOS. And now, with a stable release, we come to see the apps that you will build with Compose Multiplatform.
We know that when you're working on UI, you want to see your code changes reflected on the screen as quickly as possible. We're making this experience better than ever before with Compose Hot Reload. Let's see how. Here's the Kotlin conf app again, running on the desktop JVM target with Hot Reload enabled. As we make changes to the code, tweaking paddings, colors, and sizing, Hot Reload recompiles the code and updates the UI in our live running application. We don't need to restart the app to see these changes, and we don't lose the existing state, like the current screen or the user inputs.
So, as you can see, using Hot Reload is a simple, natural experience. And you can make any change in your code, and Hot Reload will keep up. You can modify layouts, rewrite screens, or develop entirely new features, all without having to restart your app. And now the best part. You can already add hot reload to your projects and enjoy blazing fast iteration on your shared UI.
Next, let's take a look at the web target for Compose multi-platform, which is also evolving quickly. In the last year, we collaborated with browser vendors to increase performance, improved input handling on mobile devices, and added web implementations for more APIs, bringing it even closer to feature parity with our other platforms. Looking forward, the next items on our roadmap include interop features, which means you'll be able to embed HTML elements into your Compose code on the web, as well as accessibility support.
And we also have a cool new way for you to try Compose on the web without having to set up or install anything. It's now part of a Kotlin playground. So you can write and run Compose code right in your browser. And that can be pretty much any browser, as all of them have full support for WebAssembly now, which is what powers Compose multi-platform on the web. That means your apps will work anywhere, whether your users are in Firefox on desktop or in Safari on iOS.
We're also making continuous improvements to the WASM target for Kotlin. Rebuilding a WASM app is twice as fast now after making changes, thanks to the new support for incremental compilation. And you also get smaller output binaries, as we reduced their size by 30% on average since Kotlin 2.0. And of course, WASM is also fast at runtime. Kotlin WASM runs 50% faster than Kotlin JS on average, with Compose multi-platform running nearly 3 times as fast when using WebAssembly.
With all these improvements and more, Kotlin WASM and Compose for Web will both move to beta later this year. But that's still not everything we have on the web platform. On the top of our focus on Kotlin WASM, we are bringing more improvements to Kotlin JS. These include removing many of the existing limitations around interop, targeting the latest JavaScript standards, and letting you use any modern JavaScript bundlers to speed up your compilation cycle.
With that, we've seen how Kotlin multi-platform is evolving across all its platforms. Building on top of that core technology, the KMP ecosystem is also evolving rapidly. You have already built thousands of multi-platform libraries, and we are really thankful for all of these contributions. Last year, we promised to make it easier to publish your libraries. And to achieve that, we've added experimental support for cross-compilation. This means you can now build your libraries for all targets using any operating system. For example, your CI running Linux can now produce libraries that will work on iOS without a separate macOS machine. In Kotlin 2.2.20, we are enabling cross-compilation by default for all multi-platform libraries.
And now with all these great libraries available, it's important that you can actually find the ones you need. That's why we created klibs.io, an official catalog for multi-platform libraries. You can browse the most popular libraries by category, filter search results by the required platforms, and easily find the projects that fit your use case. By the way, this is all implemented in Kotlin on the back end, which Seb can tell us more about.
Hello, everyone. Good to be back. Let's talk about Kotlin on the server side, because it is one of the most impactful areas that we have for Kotlin, and it is one where all of our favorite language really, really shines. Let's start our journey with the Spring Framework, because let's be honest, it's a real powerhouse when it comes to building server-side applications on the JVM, and there's really nothing quite like it. Now, with Kotlin, you can just write Spring applications, right? Every single pattern, every single feature, every single approach to architecture is available in Kotlin as well. But of course, you get to do it with all the modern conveniences, like these ones that you as Kotlin developers know and love. These are the things that make your code easier to read, write, and of course, reason about. And of course, adopting Kotlin in your Spring applications, that happens on your own terms. With 100% Java interop, Kotlin and Java files happily coexist within the same package, and you can seamlessly call from one language to the other in either direction. But of course, it's all just the basics, right? There's more. The Spring team is actually building extensions that are specific for Kotlin that you can choose to build with. Kotlin's coroutines in Spring feel just as natural as anywhere else that you write Kotlin. For example, you can just mark endpoint functions as suspending, or you can return flows from them, and they work exactly as you would expect. When using the coroutine-based routing DSL, like I do here, I can specify my routes in a functional manner. So I can specify 3 routes in just 5 lines of code. It's natural, it's expressive, it's what we love about Kotlin. And these DSLs, they extend further as well. You can register beans programmatically, or you can use access controls in Spring Security, all super concisely and without ever touching any XML. It's the combination of all of these aspects, right? It's language, it's adoption on your terms, and it's these tailored extensions that make Kotlin and Spring a perfect match. Already we're seeing 27% of Spring developers use Kotlin today, including the creator of the framework, Rod Johnson, who's also here to give a talk today. And 27%, it's a huge number, and it is one that we want to see growing continuously. So that's why I'm very excited to announce that JetBrains and Spring are forming a strategic partnership. Our goal is to make the experience of working with Kotlin plus Spring truly excellent. And there's a couple of key directions that we're going into here. Full null safety efforts from the Spring team automatically provide additional safety to your Kotlin code without you having to make any kind of changes. Key learning materials are going to be provided in Kotlin. And we at JetBrains also started work on our much faster version of our reflection library, KotlinX Reflect. Now there's one more pairing that I want to talk to all of you about, and it's one that you might not expect. And that's Spring and Kotlin Notebook. Let me just show it to you in action. I'm sure it's going to become clear. Let's return back to klibs.io once more, which, by the way, is built as a Spring app on the back end. Let's say I want to do an analysis of the Kotlin multi-platform ecosystem. I want to figure out what JDKs are typically targeted by most multi-platform libraries. That is information that is somewhere in the back end of this application. I just need to get to it somehow. Well, first thing I could do is I'll just start the klibs.io backend from IntelliJ IDEA. And then once that's running, I can create a new Kotlin notebook. And what I can do then is I can attach it to the running Spring process. So any code that I write in my notebook is executed in the same context as the running Spring application itself. So I can now access all parts of the Spring app. For example, I can grab the package repository, and I can just call find all packages. It's not particularly nice to read yet, so I can pull in DataFrame, which is the library that we're building at JetBrains to work with structured data. So I can just call an extension function here, and all of a sudden, I have a properly formatted table, like that, with all the data split out into columns. So from here, actually extracting the data that I'm really interested in is quite easy. I'll grab myself those packages that actually run on the JVM, and I'll just dynamically add a new column. We'll call it JVM target. That one extracts the JVM target version, and we can immediately see our table be populated with these new values. So let's see the actual data that we wanted, and let's see some distributions. I can do a little bit of quick grouping, I can do some counting, and just like that, I get the overview that I was looking for. That's a lot of Java 1.8. I'm guessing, backwards compatibility is good. It's good. But here's something that's, of course, extra neat about writing your notebooks in Kotlin, right? All the code that we wrote here, it is just Kotlin code. So with very, very minor adjustments, I can just take that, and I can turn it into a deployable REST endpoint. That's part of my Spring application with truly minimal changes. And beyond that, this is, by the way, also the perfect place to see that the DataFrame library actually provides type-safe schemas that even include things that are generated ad hoc. Like here, the JVM target version that I just create like one line above of it. That is the upcoming DataFrame compiler plugin in action. It allows you to write fully type-safe code even when the shape of your data changes around. The compiler plugin is part of DataFrame 1.0, which is currently available as a beta release. So as you can see, Kotlin notebooks are a great playground to explore and interactively work with your Kotlin code. And with this new feature, which is available as experimental, they now work with all Spring applications, and that does include those that are written in 100% Java. You can still attach, explore, and prototype regardless. If you ask me, that's pretty cool. What do you think? This feature is currently available as experimental, but the rest of Kotlin Notebooks is stable, and we want to make it as easy as possible for you to start working with it as well and do the same kind of explorations. So starting with 2025.1, Kotlin Notebooks come as a bundled plugin in both Ultimate and Community, and in Android Studio, you can simply install notebooks from the marketplace. It's actually roughly 50%, roughly half of all Kotlin developers that use it on the back end, which is honestly a number worth celebrating in itself. But you're also building a lot of cool things with it. And I think it's a good time to just see and listen to a couple of the teams that do exactly that.
The tech stack we used forced us to write a lot of boilerplate code and lacked modern functional programming features, which greatly reduced our ability to adapt.
We faced the need for robust, modern language capable of supporting a rapidly expanding feature set.
We wanted a technology that felt close to Java, but would let us reduce technical debt, learn modern patterns, and prove itself under real production load.
At Wolt, our teams choose the technologies they work with, and many have gravitated towards Kotlin simply because they enjoy using it.
Adopting Kotlin has led to significantly faster feature development and a notable reduction in time spent on code reviews, especially regarding nullability issues.
The language has also helped us to reduce type miscast incidents, and our internal tools built in Kotlin now allow us to launch new services in minutes instead of days.
This success not only encouraged other teams to join in, but also led us to officially become a Kotlin-first company by 2023.
We're confident that it will continue to drive improvements in development speed, code quality, and overall collaboration across the company.
Our engineers are very happy with the codebase, and they're actively working to make it even better every day.
We are enthusiastic about the future and the continued positive impact Kotlin will have on our projects.
It's always amazing to me seeing how people build with Kotlin. Next, I want to talk about another cornerstone library when it comes to networking, which is Ktor. Well, more precisely, let's talk about its two parts. Ktor Client, which is our standard building block for working with HTTP APIs, and Ktor Server, our lightweight framework for building networked services. Now, the two are sibling libraries that can be used independently of each other, but the two still share a common core, and we've done a lot of polishing on that core as part of Ktor 3. We've moved the entire I/O infrastructure to Kotlin X I/O. So especially when transferring larger payloads, this change alone results in up to 3 times better performance, all without requiring any changes on the application code. And of course, we're evolving the framework with new features and functionality as well. We've improved work with configuration files, server-sent events with heartbeats and serialization integration, WebAssembly support, and we've also started work on actuator functionality that allows you to introspect your app with health checks and metrics, all of these kind of things. Ktor's adoption is actually growing very fast, up 37% over the last year, and we want to keep evolving the framework with the needs that you have as its users. There's one more library that I also want to talk about, and that is Exposed, our library for working with SQL. Exposed allows you to express SQL queries using a fully type-safe Kotlin DSL without ever really diverging from any of the core SQL concepts. But if you want, we also have an optional DAO layer that allows you to work with your data in an object-oriented approach that's even more concise. Now, the team behind Exposed has worked extremely hard these recent months and has reworked pretty much every single aspect of Exposed. They've rewritten the core of the library, new SQL features were introduced, and with new onboarding materials and more love for the documentation, working with Exposed has really leveled up. And with its new IDE plugin, you can also now enjoy truly first-class IDE support. But there is one key feature that probably really deserves the spotlight here, and that is full R2DBC support. Lots of R2DBC enthusiasts in the house, it seems like. Well, what does that actually mean? Well, it means that Exposed can now work in a fully non-blocking fashion. It's an integration that we've built on top of coroutines, so your typical database operations, like inserts, like updates, they are exposed naturally through suspending functions. Or you can have the results of your queries be returned to you as flows, so that you can process results over time. Now, we're currently putting a couple of final touches on the framework. But we're rapidly approaching the point where Exposed has a fully stable API surface and will be ready for truly all production use cases. And soon, we'll be promoting Exposed to 1.0. And now, to wrap things up, please welcome Hadi Hariri.
Thank you. Hi, everyone. How are you all doing? Wow. Yeah, so you've seen a lot today. Let's wrap it up. We'll go quickly. We've seen a lot about the Kotlin ecosystem. We have seen AI. You like it or not, we've seen AI. We have seen KMP and Compose multi-platform, and of course, server. But then all of this is about what? The language. And we all love the language, yes? Show me some love for the language. And we all love the language, and we think the language is amazing. And at JetBrains, we also know that what makes a language amazing is good tooling. And we provide you with that good tooling. IntelliJ IDEA gives you good support for Kotlin. But here's the thing. We want more people to use Kotlin. We want more people to love Kotlin. We want everyone to enjoy what we're enjoying, independently of what tool they want to use. And that is why I'm extremely excited to announce official support for Kotlin Language Server. Along with a VS Code extension, you can now get code completion, quick fixes, inspections, interoperability with Java, project import, and many other things. You can already download this and play with it. It's a pre-alpha. Why is it a pre-alpha? Because we don't want to call it an alpha. We'll call it an alpha when we're ready to call it an alpha sometime later this year. But please use it, break it, give us feedback, etc. And yes, and then make sure you continue with IntelliJ IDEA. Anyway, so you will, over the next 2 days, you're going to learn a lot about what's happening with Kotlin. Enjoy it, have fun, but remember that the conference is more. Please make sure that you visit our exhibitors who are out there on the hall. If you want to try your luck and win some prizes, take the Kotlin Conf Coding Challenge. And then also there's a lounge in the back if you are just bored and want to catch up on email. Then we have Code Labs by Google that's taking place if you want hands-on experience to really try and test the frameworks and libraries that folks are creating. And then for those of you that are in education, whether you're university or teachers, we've created a small discussion group for you tomorrow after the Code Labs, which is called Kotlin for Educators. All of this information you can get from the app. As always, download it on any device you like, and please also use it for voting for sessions. Of course, tomorrow there's the party. Sorry, tonight there's a party. Yes, tonight there's a party. There's going to be a live band. Unfortunately, there's no karaoke, so you're not going to get Eminem, but I'm open to ideas there. Closing panel traditional is happening tomorrow. We've just slightly changed it, and you take a scan of that, and then you will ask questions on Slido or upvote for questions. Don't do it now. it's everywhere. Enjoy, embrace the moment. Enjoy. When you go to a conference, everyone's like with their phones. Not a conference, a rock star thing, kind of thing, a rock band. Anyway, talking about that, I would just want to close with a few words. This is Kotlin Conf 2017. Who was there? Woo. Yeah, woo. Thank you, woo. It was amazing. And when we decided to put on a conference, I was really, really scared, really, because I'm like, will more than 200 people show up? And 1,200 people showed up, and we sold out. This is the 6th year of Kotlin Conf, and we have 2,100 people here. And I just want to say that this is possible, and everything that we're doing possible is possible made by all of you. Made by the 2,100 people here, made by the 70,000 people that are a part of the Kotlin community, and by the millions of developers that are using Kotlin every day and loving it. You folks give us the energy to do all of this, and I'm extremely grateful to all of you. So thank you, and enjoy the conference.